Assalamualaikum. This is a presentation of project designing the centrifugal pump. We are from group ECOP and our group members is Muhammad Ramizan, Muhammad Faris Akil and Muhammad Erizwan. So what is centrifugal pump? A centrifugal pump is a mechanical device that is designed to move a fluid by transfer of rotational energy from one or more rotors called impellers. So this impellers is rotating and the fluid will be casted out by the centrifugal force along its circumference through the impeller's vent tips. So the action of the rotating impeller will increase the fluid's velocity, the pressure, and will direct toward the pump outlet. So there will be two types of centrifugal pump, which is a non-self-priming pump and self-priming pump. But for this project, we are focusing on the self-priming pump. So this self-priming pump is the same as other centrifugal pump, but it is designed with an external casing that actually floods the inner pump or volute. Actually, the casing is filled with liquid and it is it can just be pumped without having cavitation. With the client's request, we have to do the design of centrifugal pump that can deliver higher flow rate from the current 24 millicube per hour by 35% to 30 millicube per hour. Next, we are going to calculate on the pressure drop of the plant or the system. The formula is HA equal to HGO plus summation of HV, whereas the HGO is 6 meter and the summation of HV is the HV suction pipe plus HV delivery pipe from the picture. So to calculate HV suction pipe and HV delivery pipe, we must know all the components that been used for the design. And from that, we calculate the pressure drop by multiplying the summation of all components pressure drop to pressure drop due to viscosity. So the pressure drop of components can be found from the table here. And the pressure drops depends on the viscosity can be found here. This is for the N65 and this is for the N50. So from the graph, we just extrapolate the Q equal to 30 to get the HV value. Then we must find the NPSH, which is 7.88 meter. And based on the parameters that we have collected, which is Q equal to 30 millicube per hour, required flow head 41.62 meter, and NPSH available 7.88 meter, we extrapolate on the graph diagram of a centrifugal pump TPS 30, 50, 2 pole and 50 Hertz. We extrapolate the NPSH graph, we get the NPSH required by 2.5 meter. And we use the impeller diameter of 210 millimeter. Next, after we extrapolate at Q equal to 30 and the flow head of 41 meter, we then get the pump efficiency about 39%. And we extrapolate the required motor power graph. we get the power required by the plant is 10.2 kilowatt. So based on this, we can now pick the suitable motor power. So this is the TPS 3050 two-pole of 50 Hz. So from the motor power given, we will pick IEC 132M of 11 kilowatt. The suitable impeller diameter would be 210 millimeters since the higher flow rate can be achieved. Hence, this design can be used for higher flow rate than 25%. So our conclusion, the centrifugal pump design we will be using type of TPS 3050, speed of 2 pole, frequency 50 Hz, impeller diameter 210 millimeter with the motor power 11 kilowatt. That's it. Thank you.